So welcome everyone. Thank you very much for joining us today. This is the second in the series of webinars that the IEA is holding, providing some deep dives into the findings of this year's World Energy Outlook. Yesterday, we heard about electricity and the age of electricity. Today, we're going to be focusing on some of the implications that we see in the years ahead for fuels, for oil, coal, gas, and for low emissions fuels. I'm joined today by a number of the key analysts who've been working on this year's outlook. We've got Apostolos, who's the lead analyst on transport, Courtney, who looks at oil supply and many other issues, and Peter, who is the lead gas analyst in the World Energy Outlook team. And we're going to speak through many of the key topics. But before we do that, I want to just provide a little bit of context on some of the two key findings that we had in this year's outlook. The first was on energy security. Energy security is a foundational aspect of the IEA, and we, of course, look into it in a huge amount of detail. And we will be speaking through some of the implications that we see for energy security in the years ahead and how the differences for oil, gas, and coal markets will be evolving. Another key topic that we had looked at is that we see that we are now moving into the age of electricity. One of the key reasons that we had the webinar yesterday, providing deep dive onto that. But while we are, of course, moving into the age of electricity, when we see all of the changes in the energy system today, we can't forget that even though electricity is growing very, very rapidly, the foundation of the energy system today is still fuels, and predominantly fossil fuels, oil, gas, and coal. We look at the mix of total final consumption. This is the energy that consumers actually use in their homes, in buildings, in industry and transport. When we look at that, we see that fuels comprise about 3/4 of total final consumption today. And when we look ahead, if you look into our state of policy scenario, we see that electricity demand will grow very, very substantially. It will comprise an increasing part of total final consumption. The stated policy scenario, that's the scenario that just takes on board those policy settings that governments have in place today and those that they have announced. It's where the future looks very much like the past. In that, we see this huge growth in electricity, but still there is a very, very substantial role for fuels. There's an increasing role played by low emissions fuels, but still the majority is fossil fuels. In the IEA, we don't have a single vision for the long-term future. We have a number of different scenarios, and two of the other scenarios that we look at are much more climate-driven scenarios. So these are much more where we work back from certain climate objectives. In our announced pledges scenario, this is where we take on board those pledges, those long-term net zero pledges that countries have announced around the world. So, for example, the European Union has announced it wants to achieve net zero by 2050. China has said net zero by 2060, India by 2070, and so on and so forth. And in that scenario, we see an even greater role for electricity and an even greater role there for low emissions fuels. But even there, we don't have no fossil fuels. We still have a substantial role played by fossil fuels going forwards. And our final scenario, which we call our net zero emissions by 2050 scenario, this is where the world comes together to try to limit the temperature rise to 1.5 degrees scenario. We see a huge role for electricity going forwards. Low emissions electricity is the key mechanism by which we achieve net zero by 2050, but it's not the only mechanism. We again have a very important role for low emissions fuels like bioenergy, like hydrogen, like biomethane, and many other sources. And also, even in this scenario, we don't have a complete elimination of oil and gas. There are still some sectors where oil and gas continue to play a role. And so it's within this context that no matter what the future looks like, fuels are going to play a very important part in the energy system, that it's worth looking into the details on the individual fuels here. And so with that, I'm going to hand it over to Apostolos to talk about oil demand.
Thank you, Christoph. Let's speak a little bit on the oil demand outlook. So take a step back and look what it has happened over the years before. between 2015 and 2023, we have seen that the oil demand at global level grew by 5.5 million barrels per day, from which 90% of the growth came from China, primarily due to what it was happening on the petrochemical sectors and road sector, of course. This is followed about from the second largest growth came from India, over 1 million barrels per day, followed by Southeast Asia, Africa, and Middle East. However, this is the situation, what we have experienced in the past, and this is our outlook in the stated policy scenario, which, as Christophe mentioned, it's the scenario that we take on board stated policies. And we see there a different role China to play on this market, where it's more or less oil demand growth. It's stable due to the fact that it shifts a lot of its, especially the road sector, from oil-based fuels to electrification. Just to point out an interesting point there is that China, by end of this year, it expects to surpass 10 million electric car sales by the end of the year. At the global level, we do expect the global electric car sales to reach 17 million. Of course, how the electrification is going to move forward, we do see that from 17 million today by the end of the year to reach over 40 million in 2030 and 55 million electric cars sales will have at global level by 2035. This has strong implications also for the oil demand, which the EV sales, they saved 6 million barrels per day in 2030 and over 10 million barrels per day by 2035. This brings down the oil demand growth and also leads to a peak by the end of this decade. By 2030, we expect an oil peak, and then in 2035, the global oil demand, it will remain similar to today's level. This is one of the points what we see on the global level. And the second also, on top of that, we see also a different structure about where this oil demand growth comes. In the previous year, we have seen this was mainly China, but in the future, we see this, it's mainly India, Southeast Asia, Africa, and Middle East. But even if you combine the growth that we see in the picture from these three regions, this growth is still less in terms of volumes compared to what we have experienced coming from China. And of course, there is a lot of uncertainties there, and particularly when we talk about oil demand growth and oil markets. And for this reason, these years, apart from the assessment about the different scenarios that already Christophe mentioned earlier, on top of that, we had some sensitivity cases about key factors that can affect the oil demand, particularly. For instance, one of the key factors that's widely discussed, it's about the penetration of EVs. And of course, the penetration of EVs and how quickly EVs are penetrated and are going to be adopted, it depends from a range of factors. We're talking about like consumers' preference, policies in place, recharging infrastructure. So all of that are combined together. They drive their outlook. And on this particular case, we see we run a sensitivity case where we see what is going to happen if we see a slow EV uptake, especially on advanced economies, in case that we see a delay on reaching some targets. And on this point, by 2035, so the electric car sales will be 10% less compared to what we have assessed during in the STEPS scenario, and this leads to a growth of 2 million barrels per day in terms of oil demand. On the other side, what we have seen also from the latest data, it's an even stronger growth on EV sales, particularly on emerging market and developing economies outside China. On the first 3 quarters of this year of 2024, we have seen an around 100% growth versus 1 year ago. And if this trend is going to continue, we do expect a stronger growth of electric car sales that by the end of the period that you see on the figure in 2035 are adding up around 10 million electric car sales on top of 55 electric car sales that we have assessed on the step scenario, and this leads to a drop on oil demand by 1.8 million barrels per day. Of course, the two sensitivity cases are not symmetric, because it really depends on what type of markets that you affect. For example, on the case where we have seen faster EV adoption, it's literally the markets, they play a strong role in terms of oil and also in terms of car fleet as general beyond 2030. And now I'm passing the floor to Courtney.
Great, thank you, Apo. So let's also then have a look at the supply of oil and where that's coming from and how that's changing over time over the next decade. Basically, as we see, despite this demand peak in oil, mostly notably related to fuel transport with the adoption of EVs, we still have growth in oil production across a number of different geographies. So first on this slide, showing that the increases in oil production between 2023 and 2035, we see Guyana, a relatively new petroleum producer country, and they're going to continue to grow in their production as majors such as ExxonMobil continue to develop resources which have already been identified. And that'll really start increasing the production over the next decade in Guyana. In the United States, which has been the country leading growth in oil production over the last 15 years or so, especially with the shale revolution, United States oil production will continue to grow, but has been displanted by Guyana as the #1 in growth. And then this is followed by Canada and Brazil. So what we call these 4 countries, as they are in North and South America, it's a quartet of countries that are leading the production growth and giving security across a spectrum of across the Western Hemisphere. But you also have production increasing in Saudi Arabia, for instance, that is representing OPEC here on this slide, as well as Qatar. And then Argentina is continuing to grow their barrels, and we expect that to continue to increase with the Vaca Muerta developments, as well as some other developments happening across that nation. So there is still oil supply growth that is matching the demand that is needed. But also what we see, especially for OPEC Plus, is that we're starting to see a surplus, actually a surplus of spare capacity of oil that is also going to be something to keep an eye on going forward to see how that might be impacting production and price. Then we want to turn a bit towards coal as well. So coal is an important element from a climate emissions. From a climate perspective, there's no. I'm sorry. So global coal demand remains stubbornly high, despite the changes in other sources of electrification that might be available for power, for example. But we see this starting to come down over the next decade in the STEP scenario. We also see industry bringing coal demand down, as well as other sectors. Half of the global coal demand today is taking place in China, and India and also other Southeast Asian countries are set to become important drivers of future demand growth. And we see a very different picture in the APS, where we should see a more steep decline in coal use and coal demand, especially in power, but also across industry. So the coal use will fall much faster based on announced pledges.
Thank you.
Sorry, then I turn it over to Peter to talk about gas.
Sure thing. Thank you very much, Courtney. So the role of natural gas in the world energy outlook varies depending on geography, depending on the sector, and the time frame that you find yourself in. There's no single storyline for natural gas. In this year's World Energy Outlook, in our stated policy scenario, demand has been revised upward compared with last year. And that reflects stronger anticipated demand for gas to meet growth in electricity demand in China, as well as additional demand in places like the Middle East, where policies to shift away from oil in electricity generation have been made more robust. So in the steps, the level of gas demand is up by about 130 billion cubic meters compared to last year. And that means that overall demand reaches a high point of around 4.4 trillion cubic meters by 2030. But as we also affirmed last year, as with all other fossil fuels, natural gas demand under today's policy settings is poised to reach a peak and then a very slight decline through to 2050. Now, this trajectory is largely a consequence of the accelerating deployment of renewables, efficiency gains, the electrification of end uses, trends which are accelerating around the world. And if we put even more ambition behind governments in our announced pledges scenario, then natural gas demand falls even faster this decade, and it's almost 20% lower by 2035 than it was in 2023. Now, in a scenario reaching global net zero emissions by 2050, demand would roughly fall around 5% per year over the next decade. So a very sharp downturn for gas use across all markets. Now, these global results do mask some important regional distinctions in the outlook for gas. So in emerging markets, we still see strong growth in the Middle East. In emerging markets in Asia, natural gas demand continues to provide power, fulfill uses in industry and also to an extent in buildings. But at the global level, this is compensated for by reductions in advanced economies. Now, Europe and also to an extent Japan lead the way in terms of overall declines over the next decade. And that's also joined by the United States, thanks to the renewables and clean energy support schemes found in the Inflation Reduction Act. So very different trajectories across the board for natural gas, even over the next decade. And if we shift across now to the supply side and consider the implications there, a lot has been written and thought about around LNG markets and what the impact of a new large wave of new capacity coming online over the next decade. So that wave is unprecedented. It's the largest addition of LNG in the space of time of around 5 years. If all these projects are completed on time, the available capacity is expected to rise from about 600 billion cubic meters per year today to 850 by 2030. Now, we've seen some delays to projects announced over the last few quarters, and that has led to a bit more nervousness in global gas markets, a tighter supply-demand balance in Europe. But by 2030, it's clear that there's a lot of new LNG supply coming. Now, where is that supply growth coming from? A lot of it is the US and Qatar. Now, these two countries are already the two largest LNG exporters globally today. And by 2030, they dominate global LNG supply, accounting for over 50% of the world's LNG. And now, if we think about where all this LNG will go, if we look at the past, we saw that previous waves of LNG supply growth were earmarked for places like China, which was growing the share of gas in its energy mix, as well as the European Union after the cut in Russian pipeline supplies following Russia's invasion of Ukraine. Looking ahead, the potential for more growth in LNG demand, both in Europe and in China, is a little bit more muted. These are regions where clean energy is growing the fastest. There's rapid deployment in China and in the European Union of solar. There's rapid efficiency gains. Europe is making a lot of efforts, is taking a lot of effort to reduce the use of gas in its energy mix following the energy crisis. So instead of those two sort of linchpin engines of growth in LNG supply in the past, LNG demand in the past, we're looking to markets around Southeast Asia, India. These are markets that there's a lot of expectations that these markets can absorb additional LNG just by virtue of their large appetite for energy demand overall, their very fast growing electricity markets and so on. But it's not at all clear that these markets could absorb all of that LNG. Prices would need to fall very, very low to stimulate coal to gas switching, for example, or to stimulate additional uses for natural gas. These are markets that have in the past relied on domestic natural gas supply at a relatively low cost of production and sometimes a regulated or a subsidized price for large off-takers. So there is an imbalance there. New LNG suppliers require $6, $7, $8 or more per MBTU to make a profit on their supply. And these markets that are very price sensitive tend not to bring in a huge amount of additional demand unless prices are potentially lower than that. So if we go and to the next slide and revisit our trajectories, in this year's World Energy Outlook, we explored a lot of sensitivities and uncertainties around our stated policy scenario. What could happen? What could be different? How might the world look differently to the one in the stated policy scenario? And for gas, it's a question of whether gas demand could continue to grow as it has done in the past. So as the IEA said in its 2011 report, the 2010s would be a golden age of gas, and indeed gas grew very, very strongly over the last decade, almost 3% per year. And in the last 5 years, it slowed down. Obviously, the pandemic and the energy crisis played into that, and demand growth has slowed to about 1.2%. But even to maintain this moderate level of demand, you would need to take assumptions that deviate quite sharply from the stated policy scenario. For example, renewables such as wind and solar would no longer grow beyond deployment levels seen in 2023. So if we froze wind and solar deployment at those levels, then there'd be more space for natural gas to grow in the power sector. If we thought that efficiency could no longer improve past the rate it is today, then that would obviously allow gas to grow in industry and also in electricity uses. And lower gas prices would also potentially stimulate large-scale coal-to-gas switching, far beyond what might be visible in the steppes. But this would require not only competitive prices for gas, which would be below $5 an MBTU, but coal plants would have to run much lower, even in markets where their use and their operation is already regulated. So prices are not the only arbiter of determining the role of gas in the power sector, but indeed, if you wanted gas, if gas were to grow at levels it has done in the past, coal to gas switching would have to happen at scale. So these are some of the conditions at which you would see gas to grow beyond the levels that we see in the steppes. And potentially then that would absorb the LNG surplus that we would otherwise see in our scenario, which is around 130 BCM of gas. So I'll just round things off with a quick look at low emissions fuels. So as Christoph mentioned at the start, our scenarios see rapid growth in electricity, but even in the NZE, the net zero scenario, almost half of total final consumption in 2050 consists of fuels, and a quarter of that is in low emissions fuels. So what we mean by that, we mean biofuels, advanced biofuels, modern bioenergy, hydrogen, and biogases, and also indeed synthetic fuels. So these are fuels which in some cases drop in as a direct replacement for fossil fuels. So an example would be biogases that are upgraded to biomethane, sometimes called renewable natural gas, which can be directly injected into gas grids. Or advanced biofuels based on feedstocks such as used cooking oil, which can be used as drop-in substitutes for diesel vehicles. So there's been a lot of interest also in developing low emissions hydrogen in recent years. Our latest hydrogen review finds that even though momentum has declined from the initial wave of enthusiasm for hydrogen, there's still around 50 million tons per year of hydrogen capacity that's an announced project. And those that have taken final investment decision amount to around 3.5 million tons per annum. So this is still noteworthy progress for a very nascent sector. And you see here for hydrogen in particular, you know, it has a very strong role to play in transport, in heavy duty transport. So you know, in shipping or in energy intensive industries like steel, chemicals, or cement. Low emissions fuels in general also have a strong role in perhaps backing up power systems with low emissions, dispatchable electricity, and storage options. Now, this is, of course, a complex world involving large-scale capital-intensive projects, and currently many of these fuels are not competitive with their incumbents, so fossil fuels. And if we were to see them at scale and to meet the ambitions set out in our announced pledges scenario, much more work would need to be done to create the enabling conditions for these fuels to grow at scale. So that means supportive infrastructure, certainty of demand, overcoming delays to regulatory regimes or to permitting, and other issues, operational challenges that face the sector. So public support still very much required for these fuels and technologies in order for them to reach the scale envisioned in the announced pledges scenario. And with that, I'll hand it back to Christoph to round things off.
Thank you very much, Peter, and thank you to Courtney and Apo for that really insightful look across the different fuels. And just to kind of bring it all together, I just wanted to finish with a few words on investment and what all of that, those pictures mean for investment. If we look at investment into fossil fuels over the past 7 or 8 years, we see that there was a big drop in 2020 as a result of COVID, but investment into fossil fuels has been growing steadily over that period since the pandemic. And when you compare this to what's required in the scenarios going forwards, if we look back at what the situation was prior to the signing of the Paris Agreement, before we saw a huge wave of new policies coming through from governments, we saw that we needed close to $1.5 trillion of investment into fossil fuels every single year. And actually that the levels of investment that we see today wouldn't have matched the levels that would be required. But since the signing of the Paris Agreement, because of all of these changes that we've been discussing, with that peak in oil demand, with the peak that we see in gas demand and coal demand, the investment that's now required in this year's state of policy scenario is significantly lower than what we saw prior to the signing of the Paris Agreement. And actually, the total level of investment that we have into fossil fuels today is greater than the level in the state of policy scenario in 2030. But the only way in which you can have that level of investment into fossil fuels, if we are to maintain energy security, if we are to maintain a situation where we have reliable supplies of energy and of electricity, is we need to see a very large growth in clean energy. And in fact, absolutely, we have seen that in recent years. If we look back in 2015, we saw that roughly speaking, for every dollar that was invested into fossil fuels, about $1 was invested into clean energy, whether that was into low emissions fuels, as Peter was just discussing, or into electricity, or into efficiency measures and many, many other clean energy areas. But if we fast forward to the situation that we expect to see this year, actually, for every dollar that's invested into fossil fuels, we have about $2 that are invested into clean energy. And that break between investment into fossil fuels and investment into clean energy grows further and wider in our state of policy scenario, so that by the end of this decade, we see that we have well over $2.5 trillion going into clean energy with continued growth in that upward slope that we've seen. And that means that in 2030, roughly speaking, that we're closer to $3 are invested into clean energy for every dollar that is invested into fossil fuels. So with that, that concludes our presentation, our slides. But we want now to open it up to questions that you may have to answer any aspects, whether that's on oil, gas, coal, investment into low emissions fuels, any aspects that you would like to find out more. Please do just drop them in the chat and we will do our best to get onto them. And I see that a few have already been coming in, and I'll perhaps direct the first one of these to Apo because it concerns oil demand. And that is, what's the biggest single uncertainty that we see for the outlook for oil demand going forwards?
Many thanks, Christoph, and thanks for the participants for their questions. So when we look the oil demand and in general oil markets, there are a range of factors that can affect the future. For example, we have seen like the less robust growth on oil in China on this year. It leads to just the annual growth of the global oil demand to be well below 1 million barrels per day for this year. There are other factors, for example, as we mentioned in terms of like how the petrochemicals sector is going to evolve in the future, in terms of aviation activity also plays a role. But while we are doing and putting together all these different uncertainties in the world energy outlook, so what as a key driver we see it's also the electrification and particularly EVs on the road sector. Just to put in the perspective, like today, around half of the global oil demand it's contributed to road sector, and for this it plays also a key role about the future. In this year outlook, we run different sensitivities about the electrification, the penetration of plug-in hybrids, what is going to happen in Middle East in terms of oil use on power sector, but for taking all these different sensitivities analysis into account, by far the largest component was definitely EVs, which, for example, what we saw previously, we do expect to have an impact around 2 million barrels per day, either on the upside or the downside in terms of EVs penetration.
That's great. Thank you very much, Apo. And sticking on oil for the time being, a question to Courtney that's come in is in relation to refining. We've heard about the picture for demand. We've heard about it on the supply side. Of course, refining brings these things together. So I was wondering if you could say a few words on what we see happening on refining, both in the state of policy scenario and in the other scenarios that we have.
Yeah, thanks, Christoph, and thanks for the question. So refining is at an interesting crossroads right now, because what's happening with the oil supply that we saw coming in, there is a great deal of conventional oil, but there's also a great deal of gas bringing in natural gas liquids, which tend to have different end uses. So as the middle conventional sort of black oil that can be turned into fuel, as demand for that changes, the actual setup of the refineries need to also change to use more advantaged resources going forward, to use those lighter ends and to also use the heavier ends in order to produce asphalts and bitumens and that sort of thing that you need for industry. So we see a lot of major oil companies that are integrated and have the ability to change up their refinery capacity and also the kinds of materials they're refining and what they're refining them into different feedstocks. Then I think that you see that the difference is playing out with how they are running their companies and how they are investing in refining going forward. So you're going to see some changes in how major companies are investing in refinery, how they're changing the types of fluids they're dealing with, and how they're feeding into different kinds of feedstocks that's going more to petrochemicals than to fuels.
Thank you, Courtney. There's a few questions now that have come in on the low emissions fuel side. So I'll perhaps turn some of these to Peter and perhaps combine a couple, and Peter, take them how you wish. So the first is that given electricity, biofuels, and hydrogen are all competing options for transport and each come with different costs for distribution infrastructure, is there any indication that you have on the option that's going to prevail or to dominate? Because this will be a very important aspect for many economies, particularly for developing countries. And a little bit related is a question on renewable fuels. We see that used cooking oil is used as a feedstock. Do you see large investments in feedstock growing and related agriculture to displace the use of used cooking oil?
Thank you, Christoph. Thank you to the participants' questions. Those are very interesting ones. On the relative competition, indeed, I mean, when we undertake a scenario analysis of the scale for the world energy outlook, we consider the energy needs by sector and across different geographies, considering the costs, the deployment potential, the resource potential of those various fuels and technologies. And so, what we find is that you can start to segment some of the fuels and to put them in the sectors where they make perhaps the most sort of economic sense. So, for example, for electricity, as Apo mentions, electric vehicles are already very well established in many markets. Their costs are coming down, and so the outlook for EVs to penetrate the passenger segment of the transport sector is very strong and very compelling. For advanced biofuels, by their nature, some biofuels you have to blend into petrol tanks. Others you can use as drop-in fuels. So there's of course differences across the different types of biofuels you might use, but they might also be strong candidates for heavy-duty vehicles and aviation. So because their costs are perhaps a bit higher, and because you need to think about the land use changes and the sustainability of the feedstocks that you're employing to develop biofuels, and you might encounter some natural limits to the amount of feedstock you can use for biofuel development. Those are valuable products that are probably best served in higher value segments of, say, transport and so on. So, in the NZE scenario, we have the net zero scenario, we have a large role for biofuels in the form of sustainable aviation fuels, for example, as well. And finally, for hydrogen, there's obviously advantages in certain use cases for hydrogen in petrochemicals and so on, and in the uses that normal hydrogen is already employed. But then we also see an outlook where hydrogen might be used for long haul transport, for industrial uses, and other areas where direct electrification is impractical. And then on the question for, I think you mentioned used cooking oils as a feedstock, do we see large investments growing? We track this. Our renewable energy division looks at this every year in quite some depth. And indeed, we identify it as an attractive feedstock due to its availability as a waste product. It has minimal competition with food resources and relatively low life cycle greenhouse gas emissions, even if there's some debate about the displacement of used cooking oil for fuel, and then the use of virgin feedstocks to replace that used cooking oil. So there is an active debate there. But the key drivers of the feedstock expansion is policies like renewable fuel mandates, and other regulatory interventions like quotas and so on for biodiesels. But what we see is that used cooking oil on its own is insufficient to meet the overall demand, given all the policy targets that are in place. So this is really pushing industry to diversify the feedstocks and to look elsewhere for other emerging feedstocks to supplement used cooking oil where possible. So that would include crops like corn stover, wheat straw, bagasse or switchgrass, and so on. So there's a range of other wastes and residues that could be employed to produce the same types of biofuels.
That's great. Thank you very much, Peter, for those answers. I'll keep rotating around. So another question that we have, which perhaps can go towards Apo, is on the projections that we have for EVs. Obviously, most of the time people, when they think about EVs, are thinking about passenger cars. They're the ones that receive the most attention. But do your projections include freight demand as well?
Thanks, Christoph. Yes, absolutely. So yeah, in our projection, we do include also the different truck categorization. Either are delivery trucks, what we call light commercial vehicles, either medium or heavy duty vehicles. So we have all these different vehicle categorization into account. We take them into account. Of course, lately, what we see is a stronger growth that it comes particularly from electric cars. For this reason, most of the time we're covering particularly these trends, but we see strong growth. It comes also from heavy trucks, for example. Just to point out that, like, if we take into account last year, 2024, around 10% in terms of market share of heavy trucks in China were electric. So we see things are moving forward also on this vehicle categorization, particularly in China, but also in other parts of the world. For example, in Europe, we see this to surpass 1% compared to 0.5% last year. So we see things are moving also towards electrification on this direction too.
Thanks very much, Apo. Shifting the conversation slightly now, perhaps this is one for you, Courtney. What's the impact of methane emissions on the growth of different biofuels versus oil and gas?
Well, first of all, as we know, oil and gas industry is a major source of methane emissions. And just to point out, it's important to remember that reducing those emissions by 75% in the next couple of years is going to be really critical to staying within our climate Paris Agreement targets to stay well below 2 degrees Celsius. So just to say that the oil and gas industry and coal remain very important sources, or very dire sources of methane in the atmosphere. And there are a number of abatement methodologies and monitoring methodologies that can be used and implemented now today in order to reduce those. And in terms of where those emissions are coming from, to get to your question about biofuels, in the oil and gas industry, a lot of those emissions are coming during the production. There can be a number of leaky situations where the oil and gas, the methane is leaking during the actual production in the Scope 1 emission scenario. In biofuels, that is less of a problem. But in both cases, at the end of the day, you are still combusting a hydrocarbon, and so there are going to be emissions associated with that as well. So while there is an opportunity with biofuels to be much less emissions being produced at the front end of the process, we still have to make sure we understand and control emissions at the other end of the process when you're combusting.
Thanks very much, Courtney. Now to Peter, the scenario for gas use, where it stays relatively high, either in the form of LNG or through pipelines, that's linked to emissions throughout the whole value chain. Have you estimated what the impact on global CO2 emissions in this scenario, I presume this is for the stated policy scenario, what would be the impact on CO2 emissions in that scenario?
Thank you, Christoph. Again, a very good question. So, you know, the analysis that we carried out for the sort of counterfactual to the steps where gas continues to grow wasn't an entirely modeled scenario. So normally in a scenario analysis, you know, if demand is higher, you would then have additional supply investment, you know, across different geographies. You'd have more pipeline supply, more LNG, more domestic production, and then you'd have to tally up the emissions associated with those. So, you know, we track very closely the overall GHG footprint of global oil and gas supply, so that would enable us to calculate the additional emissions associated with that additional gas use. And another important factor to consider is how that gas is being used. If the gas is directly replacing coal, then you might be able to claim that that's actually saving emissions, because coal is more emissions intensive than natural gas. Up to a point, of course. If you have very, very high amounts of methane leakage associated with your gas supply, it could very much cancel the benefits of switching from gas to coal. But in aggregate, we would see that you know, coal to gas switching would lead to an emissions benefit in some cases and in some geographies. But in other cases where gas is just stepping in to fill more electricity demand or more industrial production, you know, clean energy could have stepped in to replace that gas. So that would mean an additional amount of emissions associated with that volume. So it would be a matter of breaking everything down in that respect. We do publish the emissions associated with natural gas in the stated policy scenario, and we have some estimates of the amount of gas demand from coal to gas switching, which would enable, you know, readers to derive those estimates on their own.
Thanks very much, Peter. There's two other questions which perhaps I might quickly address. And again, please do drop any other questions that you have into the Q&A. The first is on nuclear, that we didn't mention nuclear. That was one of the aspects that was discussed in the webinar yesterday, so we didn't want to talk about it too much today. But I did want to flag that we are currently working on a new report looking specifically at nuclear, and in particular how the financing for new nuclear and for lifetime extensions can work. So the IEA has always had a big focus on nuclear and the important role that it plays, and you will be seeing other publications that we will be putting out on nuclear in the coming months. And there's also a question here. It refers specifically to ExxonMobil's outlook, which has higher oil and gas than we have in the stated policy scenario. And how do these things compare? We, of course, look at many of the other scenarios that other organizations produce, whether that's the International Information Administration in the US, whether it's oil and gas companies, whether it's renewables companies. We look at all of the other scenarios that are out there, but of course the scenarios that the IEA produces are totally independent of those other scenarios. But of course, there's a lot of interest in the other scenarios that are out there. We looked at, for example, the differences in the oil demand outlook that Apo talked about. Is actually really not very different in the stated policy scenario between demand in 2035 and in 2050 in the stated policy scenario versus many of the other oil outlooks that are out there. In particular, the Exxon outlook, the total level of oil demand really is not very different in the long term. Gas is a little bit of difference, and sometimes people are a little bit higher, a little bit lower. But one of the key things that we see is that in that scenario, in that stated policy scenario, while we have a peak in oil demand, gas demand, and coal demand, the declines in fossil fuel use after those peaks are not nearly steep enough on the basis of today's policy settings. They're not nearly steep enough to achieve our climate targets. And so we need to see much further action, much greater action in terms of scaling up clean energy if we are to have that transition away from fossil fuels. There's a couple of other questions that are just starting to come in now. So there's a question on, again, on freight. And here, looking more at what's the role of biofuels and hydrogen in the freight sector. And I think Apo is probably best placed to answer that one. And then also a question on geothermal, which is very timely for reasons that Courtney will mention. So perhaps Apo, you start on freight, and then Courtney, turning over to you, question on geothermal.
Many thanks, Christoph. Interesting question there. So, of course, there is a lot of discussion about how to decarbonize the transport sector. And particularly for road, the patterns that we see is that particularly electricity, it does make sense from economic perspective, from infrastructure needs perspective on lighter vehicles, particularly, for example, on cars, on 2-3-wheelers, which is the case for especially for emerging market and developing economies. It's less known in advanced economies, the penetration and the fleet of the 2-3-wheelers, but also for buses, especially for city buses, we have seen high share of electrification is happening. And when it goes on the discussion on freight, there is always this distinction that it comes in mind, and what we have seen that for light commercial vehicles, also electrification, it does make a sense. And there is a categorization of trucks, medium and heavy, where hydrogen potentially will play a role. Of course, in general, biofuels will continue to play a role across all the different vehicle types, where you don't really specify when you go on the refueling station what type of vehicle you are going to fuel. You just have a blending share of biofuels, and biofuels are going to play a role in the future across all of different vehicle types. But particularly what we see is it's happening is that for heavier segment, we see hydrogen to pop up and to make inroads to play a role. Of course, this transition, it will happen especially beyond 2030. The main challenge is there, it's about the cost of the hydrogen, how you're in a situation where you produce hydrogen in a cost competitive way, and this is linked on what is happening on the transformation on the power sector. But even on this area, we see that battery electric vehicles have started competing versus, I will say, fuel cell vehicles. Just to have in mind, the models that are available on different markets, either you look on Europe, United States, China, like if we take, for example, like that we have 10 models available that they run on hydrogen, for battery electric options are 10 or 15 times larger in terms of model that they are offering. This, it leads us also to the discussion and also to the outcome that also battery electric will start, and they have already started, as I mentioned before, 10% of the market share of heavy trucks in China are electric, to compete directly with hydrogen potential that we see also on this heavy vehicles area. Thank you, Christoph.
Thanks, Apo. And Courtney, geothermal.
Yes, thank you for that question. We are actually in the middle of finishing a geothermal report, which will be released on Friday. And so I don't want to steal the thunder of that report, but suffice it to say that in both power and in heating and sort of hard to abate sectors, geothermal is a source of energy that is available, distributed widely throughout the earth across all geographies, and can therefore become a secure and affordable solution. It also has significant synergies with the oil and gas industry. So as part of switching from gas and oil to geothermal, you can also be leveraging a lot of the learnings we have from, a century of oil and gas development. So I don't, again, want to steal from the report that will be launched on Friday. So please go to check our YouTube channel for that release of our report. And we look forward to showing how geothermal energy can be used to also be part of the clean energy transition.
That's great. Thank you very much, Courtney. And there's one final question that's just come in, and we'll perhaps finish off this one. So I'll answer this one myself, but how would the increase in natural disasters affect the pace and sustainability of growth in clean energy investments under the stated policy scenario? I think, first of all, we need to recognize that natural disasters, climate change has already impacted the energy system quite significantly today. If we look, for example, at hydropower, we've seen hydropower facing declining output in many parts of the world. Part of this is because of climate change-induced shifts in precipitation or variabilities in runoff, but there's also been physical damage to dams caused by extreme weather events. And so actually, if we look at the output of dams back in the 1990s, and we compare that to today, we've already seen that there has been a real reduction in output from dams. So back in the 1990s, 44%, roughly speaking, was the capacity factor of hydropower dams. Now it's down to 41%. So that doesn't sound like a huge amount, but actually it's a huge amount of generation that has been lost. That loss in generation from hydropower is roughly speaking equivalent to the global increase that we had in solar power last year. So we're already seeing the real impacts of climate damages on the system. And it's not just about hydropower, we're also seeing the impacts on heating demand, on cooling demand. These are all very important aspects. The other thing I think we should bear in mind is that climate damages are not just going to affect clean energy. They also affect traditional sources of energy supply, whether that's oil production facilities. Many of those are in areas that will be very vulnerable to climate damages. We've done detailed analysis looking at the Middle East, for example, and we see that the frequency of droughts, the frequency of extreme weather is increasing, and that could have an impact on traditional oil and gas supply. It also has an impact on refineries. It also has an impact on traditional thermal power generation. If rivers are running dry, if rivers are warmer, that reduces the efficiency of power plants. So absolutely, this is a very important aspect of considering the future of the energy system. And we are likely to see increased climate damages, particularly if we go along the stated policy scenario. The net zero by 2050 scenario is really the scenario which scientists tell us limited temperature rise to 1.5 degrees is the safest option to limit those damages going forwards. With that, it actually kind of shifts quite nicely to the webinar which we are hosting tomorrow, which is on people-centered transitions, and this will be a very, very important aspect of that. So we're going to wrap up this webinar now. Thank you very much for joining us. I won't pass it back to our colleagues, but thank you again to Apo, to Courtney, and to Peter for the really insightful presentations, for the answers that they gave, and thank you to all of you for the questions that have come through. So hope you have a very good rest of the day, and see you tomorrow. Thanks very much.